Howdy, my name's Georgie Farouk, and this is my ESET 662 final project presentation. Since I'm taking this class as a graduate level, all the work distribution falls on me. So I did everything, hardware, software, mechanical. Here's the control system's block diagram that I used to model the magic box. We have our reference height, which is set by the user. The error is calculated by subtracting the actual height, which is measured by the range sensor, and that goes into a PID controller, which gives a summed error that is interpreted by the microcontroller, which then sends a corresponding PWM signal to the fan. For the hardware, I used the same motor driver that we used in the lab to drive it. I used an Arduino as a microcontroller for the system, potentiometers as a tuning interface for the PID values, and a sonic rangefinder to measure the actual height of the ball. So software-wise, the Arduino code reads the ball's height using the rangefinder and controls the fan using PWM, which is driven by a motor driver. A PID control loop calculates the fan speed based on the error between the measured height and the desired set point. And the Arduino continuously sends the ball height and PID values to a Python script, which displays it on a GUI via serial communication. And the Python script can also communicate with the Arduino to send updated set points. So here's an example of the GUI on the right. You can see the height of the ball and the error. We also have the average height because sometimes the height changes pretty quickly and it's hard to get a grasp of what the average height would be. So that's just there to give a better understanding of the state of the system. Below it are the PID values, and to the right of that are the mathematical operands for those PID values. The system has a start and stop mode for debugging and open loop mode, which effectively removes the sensor from the Python script. So what ends up happening is basically it just blasts full PWM. There's also a live graph, which is shown in the demo video. It just shows the height of the ball and the corresponding error. I also ran the experiment to collect about a minute's worth of data, and I formatted this data in MATLAB and had it plot the various graphs you can see on the left. So our time versus height, PWM, all the error graphs, and I used that to then estimate a transfer function like was shown in class. And I managed to use, I think that's 5 poles or 6 poles and 5 zeros to get a transfer function with an accuracy of about 71%. Thank you.